Thank you all for joining and welcome to today's webinar, A+ Air Quality Sustainable Low Pressure, MERV 13 Compliance for Schools. My name is Ava Montini and I am the Senior Marketing Manager at Blade Air, and I'm really excited to be your host today as we dive into this important topic that affects not only your students, but also your staff and the overall efficiency of your school buildings. Today, we'll be exploring how schools can achieve MERV 13 compliance, a standard that is critical for maintaining healthy indoor air quality without overburdening existing HVAC systems or stretching budgets too thin. We have a fantastic panel of experts today who will guide us through the critical role of air quality in schools, its direct impact on student health and performance, and practical solutions for achieving MERV 13 compliance. We'll also hear some real-world success stories that highlight the tangible benefits of maintaining clean, healthy, efficient air quality. So why is indoor air quality so important in schools? We know that cleaner air not only improves the health and well-being of students and staff, but it also directly impacts learning outcomes in school operations. Studies show that improved air quality can boost cognitive performance and reduce some absenteeism that I know one of our panelists will be discussing. And there's also a bit of a misconception that achieving clean, healthy air in schools requires sacrificing energy efficiency, or that it's a trade-off between health or sustainability. But that really doesn't have to be the case. And this webinar is going to allow you to explore how schools can maintain high indoor air quality while also ensuring energy efficiency and sustainable practices benefiting all occupants, student, teachers, and staff alike. So to dive into this topic a little bit further, I have three industry-leading experts with us today. So first, we're going to hear from Dr. Jeffery Siegel, a professor at the University of Toronto and an expert in indoor air quality and sustainable buildings. He'll discuss the critical role that air quality plays in student health and performance and why achieving high air quality standards is essential in schools. Then we'll be hearing from my colleague, Luis Marquez, the VP of Engineering of Blade Air, and he's going to be guiding us through the practical and regulatory challenges of achieving MERV 13 compliance in schools and share some low pressure and supplemental filtration solutions that schools can partake. And lastly, we're going to hear from David Titus of Train Technologies East Canada, who will share some real life success stories from schools that have implemented some energy efficient HVAC systems, and he'll demonstrate that high air quality and sustainability can go hand in hand. So without further ado, I'd like to hand it over to our first panelist, Dr. Jeffery Siegel. Dr. Siegel, over to you.
Great. Thank you very much, Eva, and thanks everyone for being here. I interpreted my charge for this talk a little bit broadly, so I'm going to start by talking about why IAQ is so important in schools, and then I'm going to transition a little bit to how we might achieve it in a general sense to kind of pave the way for the other speakers. Before I begin, I want to mention I'm obviously an academic. And what that means from one perspective is that I'm independent. And so you might see products or other things in my talk. Please don't take them as an endorsement. I'm just trying to show my research and some of what the broader research on the subject has found. I always like to start with a little bit of history because it's so important. So we know how to improve indoor air quality. We've known it for a long time. The four basic tenets are listed there. The first one, keep it dry. It goes back thousands of years. This is a passage from the Bible, from Leviticus, that talks about what to do if you have a moisture problem in your home. And I'll save you from reading it to make two observations. The first is that as long as we've had buildings, and certainly as long as we've had schools, moisture problems are an issue. And second of all, the field of mold remediation has not advanced dramatically in the past few thousand years. Pretty much you do the same thing now. You could do a search replace on priest with mold remediator and get to pretty much the modern approach to dealing with mold. After you've kept it dry, it's really important to practice source control. The person shown here is Dr. Pettenkofer. Dr. Pettenkofer was a German hygienist who was practicing 150, 200 years ago. And he has a lot of pithy quotes like the one that's in the red box, but basically he's pointing out that you got to get rid of the sources. Everything else is going to be inferior to getting rid of sources. Now, of course, in any school or really any building, getting rid of sources is more complicated or sometimes impossible. And so we have some other strategies too. One of them is ventilation. And the people shown here are Catherine and Harriet Beecher Stowe. They wrote a book that was a bestseller around the same time period, 1860s, 1870s in the US. And they have this book about the domestic realm, how to run your home. And I put two of the chapter summaries there. And they have a whole chapter on indoor air quality and why it's important, and a whole chapter on ventilation and why it's important. And they have lots of quotes about how important indoor air quality is, how important ventilation is. And this shows that we've been thinking about these issues for a very long time. The last thing I want to talk about, because it's going to show up several times in my talk and throughout today, is about air cleaning and filtration. And the only point I want to make is that it's a very modern invention. Standard 52.2, which you might know from the MERV scale, the first version of Standard 52.2 is 25 years old this year. So it's much, much newer than any of the other information on indoor air quality we have. And that has led to, like, we don't have the same kind of experiential base with air cleaning that we do with things like ventilation and source control. And so that's going to become important to some of the things that we talk about today. So, I think that everyone who's here knows that indoor air quality is important. We spend most of our time in buildings, upwards of 90% of our time for most of us in buildings. There are a bunch of sources that are unique to indoor environments, even specifically unique to school environments, and even pollution outdoors. Most of our exposure happens indoors simply because we spend most of our time inside. Obviously, we've all had the experience of the pandemic, and many of us have had experience with things like wildfires, increased urban ambient air pollution events. And because we occupy buildings more densely, there's a lot more kind of shared air than there has been historically. So, the topic today is schools. And everything on this slide about why healthy indoor school environments is important is settled science. There isn't debate. We know that healthy indoor environments improve cognitive performance and student learning. We know that if we improve indoor air quality, we'll see higher scores on standardized tests. Plenty of data on reducing absenteeism, asthma, which some people know because they have a relative or they themselves have asthma, but rough numbers are about 25% of students in urban areas in North America have asthma, and so asthma frequency and severity are reduced when we improve indoor air quality. There is some economic data that shows that if we improve indoor air quality, students will have higher salaries when they graduate, and of course, reduce transmission of airborne infectious disease. So just to show some of that evidence basis, this is from a paper that a graduate student wrote a few years ago, and this is the basic point of this paper was to evaluate what is the evidence basis for different aspects of green schools. And just to take a tiny piece of that, which is the figure on the right here, what you see here are different things that have been studied in the literature that relate to air quality. And every time you see a shaded box, it's when there's been a study about cognitive function, C, standardized test scores, S, or absenteeism, A. And what you see here is that we have a lot of information on things like ventilation rate. We have less information on some other aspects of indoor air quality. Often that has to do with things like research funding and other things. But the overall message is that there is a ton of evidence that we should be improving indoor air quality. Just as another piece of evidence, this is some work done by a research group in Texas that shows for different cities in the US, the reduction in absenteeism you could get if you use 2-inch activated carbon filters in schools in those cities that are listed at the bottom. And so basically what you see here is that if you use activated carbon, you're reducing, depends a little bit on the city, but you are reducing absenteeism, and this is predominantly through reduction of ozone concentrations. So we can really have a big benefit. Of course, everyone wants to talk about COVID, so I'm going to show 3 lines of evidence about how we know that things like ventilation and filtration were important during COVID. The picture that's on the screen right now is from a very early study. This is from data from fall of 2020, 123 elementary schools in Georgia, and they asked a very simple question. Did you improve ventilation? Did you improve filtration? Or did you do both? And then those bars show the ratio of COVID cases to the case of the schools that did nothing. And what you see here is a reduction kind of in the neighborhood of 60, 70, maybe as low as 50% in COVID cases when schools improved ventilation or filtration. Now, we don't know what they did, so it's important to kind of get deeper evidence. So this is a study that was based on about the same time period. I forget the number of schools that were involved, but I show this for one very simple reason. So this is a study that looked at COVID cases. Higher numbers here means more COVID cases. And for different measures that schools take that were not ventilation or filtration. And the one I always like to point to here is desk shields, which is about third or fourth from the right end here. And what you see is that schools that use desk shields actually saw higher rates of COVID. And this was early evidence of something that a lot of people suspected, that, when you put impediments to airflow in a space, you actually limit the ability of ventilation and filtration to work, and you can actually make things worse. So that's a little bit of a negative case. Let's do a positive case. So the data that just came up was from a large study of schools that served intellectually and otherwise students with other types of disabilities. And they did they had a big sample of classrooms here, some of which had MERV 11 and some of which had MERV 13 filters. And what you see on the y-axis here, the higher means more COVID cases. What you see here very, very clearly is that it was statistically significant that MERV 13 filters reduced COVID cases in this school. It's a very nice study. I put the reference there. I encourage you to look at it if you have more details. One more point I want to make about the study, and I know these figures are too small to process, but that there was a weak correlation, not just with filtration, but with schools that had poor classrooms, that had poor ventilation, so had big elevations in CO2 for some fraction of the time. So ventilation matters too, not just filtration. And amount of ventilation in this study was a much, much weaker effect than the type of filtration. And so this was clear evidence to me that ventilation matters, especially getting rid of poor ventilation, but filtration can also be very, very helpful. So at this point, I'm going to talk about kind of what we do about it. And I always like to start with this slide. I'm sure many of you have seen this before. The kind of Swiss cheese model of protection. And the reason I like to show this is, even though I could talk to you all day about ventilation and filtration and the details, I think it's really important to remember that we're part of a much bigger strategy. And so our idea with ventilation and filtration is that we want to provide a layer with as few holes as possible to kind of support the overall reduction in disease transmission. And so, I think everyone has a sense of the terms. When I say ventilation, I mean fresh air from outside. When I say filtration, I mean air that has been removed of the respiratory particles or whatever you care about from the air. And, again, similar to the last slide, there's nothing magic here. These are not silver bullets that will magically protect a classroom. They're not a replacement for other things. But very importantly, they have to be done well. And I'm going to talk a little bit about what doing well means in a second. I think sometimes, especially during the pandemic or during something like a wildfire, we get focused very much on the immediate situation, and that's okay. But I want to also make the argument that these things offer many of the IAQ benefits related to absenteeism, cognitive function, and other academic benefits that I mentioned earlier. And then also, generally, we have not done as much as we should in schools with ventilation and filtration. So I think that everyone in the room knows what an HVAC system is, and you often see, schematics like the one that I've shown here. But I want to make a kind of a little bit of a different point about HVAC systems. I think if you ask the average person, you'll see a description of HVAC systems that looks something like what's in the red box. There are these kind of carefully designed systems that achieve a bunch of functions. Next, please. I don't think that's quite right, especially maybe in many of our schools. Next slide. Next, please. We have, this description that's in the box there that's probably a lot more accurate. There's a lot more complication. And a lot of people think that I'm kind of knocking school HVAC systems when I show this. I'm not. I'm pointing out that there are a lot of constraints on HVAC systems in real buildings. And in general, they've been under-resourced and under-maintained relative to what they do. And that has implications for what we can do about it. So I mentioned how important it was to do things well. I'm not going to go into a lot of detail on this slide, other than to say we have a big knowledge base on what it means to do ventilation and filtration well. And there's a lot of very basic principles that have been codified in different guidance and in some cases in standards about what it means to do well. But the bigger point is that we know how to do these things well. So I want to kind of finish the last few slides here by talking about what's our overall approach to improving indoor air quality. And I'm going to talk about 3 basic strategies. They're not mutually exclusive. Often they all have to be done together. But before I talk about those strategies, both generally and specifically, I think it's really important to acknowledge that every school is different. Every space within a school is different. And so very often we kind of have to think very broadly about strategies. And I wish there was a cookie cutter magic solution I could propose to everyone, but there's not. And so I kind of think about things in terms of how easy they are to do. And I'm going to talk a little bit about information, portable air cleaners, and then ventilation and filtration upgrades. So first, information. Oh, yeah, there's a lot of great information there. I've put some links here. I'm sure that there are many other good links of good information. And the point I want to make about information is that information is important, high quality information, but how it's provided matters as well. So it's just one example from this. This is not from schools, but I think it offers a lot of lessons. This is an effort that I participated in with a group of other people where we were interested in community congregate settings, things like homeless shelters, drop-in centers, that sort of thing. And we started at the bottom there with office hours, which we ran for about 2 years during the pandemic, where organizations could just come and ask questions about their facilities and how to make them better. We developed throughout that process a checklist of plain language guidance intended for community congregate settings. And we did things like we came out with guidance last summer in when we had the wildfire impacts in southern Ontario. And so the idea here is that you can't just have good information. You have to target that messaging really well, and you have to look at what works. So we just had a paper accepted last week where we evaluated this program, and we looked at what changes people actually made and what was feasible and what wasn't feasible. And I think that that's a really important step so it's not just providing information to a school or accepting information, it's looking at what is actually going to be effective. We all know about portable air cleaners. I think at this point we all understand they have to be sized appropriately. But aside from that, a step that is sometimes missed is you really have to get buy-in from those who are going to be using and maintaining these air cleaners. So you have to teach people how to handle noise. You've got to teach people how to handle some of the safety issues. Aesthetics are surprisingly important. Some people will say, I don't want that air cleaner because it looks ugly. And you really have to address those types of concerns. And then, of course, the costs. And in the brackets here are some ideas of how different schools have addressed some of those concerns. The other thing I always make a comment about, there's lots of alternative technologies out there. And all I want to suggest is just kind of buyer beware. There are some that are not that effective, some that are harmful. And so make sure you're using a technology that's proven and is actually going to offer benefits. The last strategy I want to talk about is ventilation and filtration upgrades. And the biggest comment I can make here is you've got to work with the people who actually operate and maintain that system. There are so many times where people have proposed solutions that just won't work for a given HVAC system. So you've got to think about things like, can the filter slot accommodate the filters you want to use, especially higher pressure drop filters that might be deeper because they're heavily pleated. So you've got to address the questions of resources. Good filters are great, but they also have to be replaced. And is there going to be the ongoing both personnel support as well as the resources to buy new filters? If you're trying to improve ventilation, you might be in an area with poor outdoor air quality, and you might have to look at how you're scheduling the operation of your ventilation system to manage that outdoor air issues. There are some times where central systems aren't available or can't be upgraded. And so you can use distributed systems, unit ventilators and similar types of technologies. And again, avoid alternative technologies. And just to forestall a question here, I often say, well, what about upper room UV? And my answer is, yeah, it has the potential to be very helpful, but it also tends to be quite expensive. And like everything else, it needs to be done well to work. And so it's not kind of an easy decision for a lot of school spaces. So I'll wrap up here is, the benefits of investing in indoor air quality for schools, is much, much bigger than the costs. And I think very often we focus on the costs, and I understand the costs are reality, but the benefits are reality too. And so we really have to do a much better job talking about the benefits so that people are making kind of sound, rational economic decisions. And so I think this is less of a knowledge gap and much more of we need to think as a community about how to overcome some of the barriers that come to improving IAQ. And I think it's important to leave on a positive message here. There's really an enormous opportunity here. Some of that opportunity has come from underinvestment in the past, but some of it also comes from people who are very primed to get this information at this point because of the experience of the pandemic. And so we have a real opportunity here for positive change. And I'll finish there. Thank you.
Thank you, Dr. Siegel, for highlighting all that important information about air quality in schools and its direct impact on student health and performance. It's definitely clear that improving air quality creates healthier, more productive, and more efficient learning environments. So now let's move on to the more practical side of things. I'd like to invite Luis Marquez to discuss more of the regulatory landscape, some common challenges that schools often face when trying to upgrade their filtration or ventilation systems, and then some low pressure solutions that can help meet these MERV 13 regulations or compliance standards without the high costs or major disruptions overall. So Luis, over to you.
Thanks, Ava. So firstly, good afternoon to everyone, and thank you for joining myself and the other panelists on this very important topic. So really appreciate you being with us here this afternoon. So firstly, I'll talk about, why MERV filtration matters in schools. As a leader in indoor air qualities, we at Blade Air really just believe that the improved air quality is the bare minimum, and it should be the bare minimum in our school systems. Obviously, Professor Siegel talked about the benefits of the good filtration, and so really getting that nice upgraded MERV rating. So we used to have standards like MERV 8, and now we know that having better filtration is much more beneficial to being able to achieve this. But another thing that we like to take a look at is the benefits of even reduced maintenance. So high efficiency filters not only give you the benefits to your students and staff, that again, we believe is the bare minimum, but it can also help keep your HVAC systems cleaner and being able to last for their entire lifetimes. At the end of the day, a lot of these systems are meant to last, a few decades, and it's important for not just the current generation of students and young adults that go through our educational facilities, but those others that come after them to also receive the same benefit and air quality that you receive at the beginning. So that high filtration is able to maintain the lifetime of your equipment and ensure that it's always receiving that high filtration that's so beneficial. Obviously, being able to meet with the new compliance and regulations. So, because of the most recent pandemic, we kind of realized that what we thought was a good enough standard for, good indoor air quality maybe didn't really actually meet the needs of students and everyone. So we've more realized that we need a higher standard to be able to really achieve this good air quality. So, you know, achieving this MERV 13 air filtration standard is going to be more beneficial to um, allowing our students to be able to focus on just their learning and not have the disruptions from absenteeism or any cognitive issues that may come from just not having that basis of just clean air. And the last aspect is kind of secondary but still important is energy and cost efficiency. At the end of the day, um, you know, schools have budget constraints that are very real, and so it's important to be mindful of not only providing these very important solutions, but doing so in a way that can be cost efficient, and in addition, able to reduce energy both for that cost efficiency perspective, but also from a green and sustainability perspective. So I just like to point out, the regulatory requirements. So acknowledging that both in the U.S. and Canada, regulation varies across the states and provinces. But really, after the pandemic, as I mentioned before, we realized and many recommend that MERV 13 or higher filters really are what allow us to meet those healthier learning environments. So we have the ASHRAE standard 62.1. This provides the general guidance on ventilation and IAQ in commercial buildings, including schools. And in Canada, IAQ guidelines also require MERV 13. I would just like to point out on the 62.1 that it does provide us with the minimum ventilation rates, which just basically means the bare minimum that any specific room should have in terms of ventilation to allow good airflow. But sometimes, and especially when looking at like the pandemic, might not be enough to make sure that everybody is fully protected. I think that comes up often when schools and other facilities try to meet these higher standards is kind of the lack of funding. So I think it's good to point out that more and more government and other entities are coming up with funding, and that schools that are able to comply with these MERV 13 standards can access, so that they are more able to meet these higher standards. Often they're tied to energy efficiency, but there are more opportunities that the schools and other facilities can access to better allow them to make this very important and necessary investment. So we're conscious that it takes these types of effort to be able to be successful. And another thing that I'd like to introduce is the more recent, newest ASHRAE Standard 241 that kind of came out of the pandemic, and just really to point out that Standard 241 acknowledges the both the need of more ventilation and higher filtration to be able to meet the scenario of a potential pandemic or other similarities, and gives more stringent needs per room than the minimum that is ASHRAE 62.1, and I'll talk more about that later. So here I'm just like to highlight some of the common obstacles that schools must overcome for better indoor air quality, and just acknowledge that these are the realities that we face in these facilities. So the first one is pretty straightforward. You know, we're dealing with students, children, young adults, and they're really a higher risk, a more sensitive group. Children are more sensitive to air quality than other groups. It's more common that they have things like asthma or other respiratory illnesses that you know, maybe some may outgrow it as adults, but some may not. And it's important to make sure that we care for these and that we don't make them worse. And then because of this, acknowledging that schools have higher standards and higher regulation than other areas that we need to meet because of these high risk sensitive groups. And then they really are just open to more scrutiny, both from the government and from parents. I have two children, so I am well aware that this is a very important reality that needs to be dealt with, but they're just held to a higher standard and higher scrutiny. Another real obstacle is just the smaller spaces and the large amount of time that a large group of people spend in these spaces. So obviously classrooms have large groups of people and we kind of cram them in there. And then, you know, when there's an assembly or something else, you know, we move them into larger gyms that cram them even more. And then obviously there's lots of different types of rooms, science, arts, home economics, which can introduce other types of pollutants and VOCs and other things into the space. Then the other two obstacles are really kind of related. The first one is budgetary constraints. Obviously, especially in public institutions, but it is true in any type of educational facilities, that the budgets are really tight and heavily controlled, and oftentimes require many layers of approval. And so when it's time to kind of cut budgets or reduce costs, it's really in this maintenance of the equipment that the funding is taken out of, since it's oftentimes not front facing. And so being able to care for these aspects, I think is very important in achieving this higher filtration and meeting the needs of the equipment. And you know, this lack of maintenance and budgetary constraints lead to an aging HVAC equipment. So you know, a lot of the schools are older, and their HVAC systems have been there for a while. And this leads to the issues that, you know, maybe they weren't designed for the current stringent regulations, and oftentimes were just thought of from what we knew from before. As Professor Siegel pointed out, you know, filtration as a whole is a more recent study that's only new to us in the last couple of decades, and obviously has now been put to the forefront because of the pandemic and the more wildfires that have been coming out. So just diving deeper into these points that I made, and kind of showing some numbers to illustrate. These are just kind of the unique aspects and the unique realities. So schools have 4 times as many occupants as office buildings, and You see in the US, the average class size is 20 and up to 25 students. And I think what I want to point out is that this has increased by 19% since the 2000s. And so it just shows that it is a larger constraint that is becoming as we cram more students into smaller spaces, and therefore there's a more need for really putting this as a priority for improving. In Canada, obviously, this is even larger at 25 students per class. And just to point out the reality of the varied types of room uses, ASHRAE 62.1 defines 16 different types of spaces for the ventilation rates in schools and educational facilities, and that's the most of any other category in the standard. And really, it shows, depending on what space, you have 5 or 10 CFM per person. And what you realize is that ends up adding up really quickly, depending on how many students or staff you cram into a single room, and can become problematic in terms of trying to achieve those minimum ventilation rates or the higher standard for filtrations. The next, just to really point out about the aging schools and the HVAC equipment in these schools. So in the US, the average age of main institutional buildings is 49 years old, and 38% of them were built before 1970. And so, only half of them have gone through major renovations in the last 14 years. And then in Canada, this was the closest date we have information for. The school infrastructure is over 50% of their lifetime in 2008. Obviously, we're well past that. And so this is just really to highlight the reality that is, a lot of these schools have aging HVAC equipment, and they were designed to, say, be using MERV 8 filters and have more lenient constraints. And now that we are rightfully, asking for higher standards, which is important, but we have to acknowledge that it is a bit difficult when these systems were not designed for such high filtration and high pressure drops for that. And so I really like to highlight here on the more stringent mandates and regulation, the updates that came with ASHRAE 241 and the equivalent clean air ventilation rates. To take the example of the schools and the gyms in schools, it more than doubles what the minimum ventilation rates are in ASHRAE 62.1. And I think to highlight the importance of that is really what it means is if we have something similar like the pandemic, or when we have events like wildfire, we acknowledge that it's more important to make sure we meet even higher standards than what we have as the minimum. And knowing that we don't want to have to make everyone stay at home or not be able to attend schools, we know that the solution is to meet these higher ventilation rates or higher filtration so that we are able to keep our students in the class. And so what these standards create is just letting us know what that minimum ventilation rate is during these higher contamination events, or like the pandemic or wildfires. And we can have solutions for being able to achieve that more easily and more cost effectively. So now I'd like to just talk about how we actually address this. And we really spoke to the two main focuses in how to achieve this from an HVAC and air filtration perspective. And it's really twofold. Increasing air ventilation and enhancing filtration efficiency. So increasing air ventilation is bringing in more fresh air, and that will improve your indoor air. Now, the obvious challenge with that is, again, if the systems are not equipped for this higher ventilation, they may struggle. Or, if we think about a pandemic and we say, hey, yeah, let's bring in more outside air, but there's wildfires outside, you could be making it worse by bringing in dirty air or pollutants in the form of VOCs in large urban areas. So then that brings me to the second aspect, which is to enhance the filtration efficiency. So things like upgrading from a MERV 8 to a MERV 13 filtration is clearly more effective for capturing more airborne contaminants. The challenge here is that once you have this higher filtration, it creates a larger pressure drop and increases the strain on the system. And in the worst cases, it stops the ventilation altogether. And so it loses the effectiveness of the filter if there's no air passing through it. I like to always say is the best filter is the one that has air passing through it. So in addition to that, it can obviously increase energy costs and even damage your system, which could be more costly to everybody if you don't have even the minimum ventilation rates that are required. So I'd like to close this part of the presentation by just pointing out a couple of technologies and solutions for optimizing the air quality with low pressure and a MERV 13 filtration. So I point out two technologies here. One is an induct solution, and another one, the portable air purification. In induct, we like to talk about low pressure filtration, things like electromagnetic filters that, because of the polarizing technology, they can achieve that MERV 13 compliance, but still keep that low resistant and low pressure. So you can improve the air quality without overburdening those HVAC systems. So you're basically getting the same pressure drop as your MERV 8s or even better, that those systems were intended for, while also achieving that higher filtration that's so important as we've highlighted through this presentation. So some of the advantages of this induct filtration, obviously when you attack the main system, you have full system coverage. These kinds of filters are designed to be able to replace the existing pleated or bagged filters, depending on the system. And so they require minimal maintenance. And that's something too that I would like to highlight is because they don't front load, those filters are needed to be replaced less often. So sometimes for schools that can only do maintenance during the summertime or during off hours where there's less disruption to the students and staff, this type of technology is prime for that because it requires less maintenance, and so therefore there's less disruptions. And then the other secondary benefit is the enhanced ventilation and energy efficiency. So with this type of technology, it's not only are you getting that higher filtration, which should be the bare minimum, but because of that lower pressure drop, that you have a higher airflow and therefore a higher ventilation. So you're really getting those two main benefits that we really want. And it reduces your energy consumption, which reduces your costs, and again, allows your system to live its full life and be able to benefit the entire cycle of the system. And then the secondary thing I do like to point out is, portable air purification. So these can add HEPA and other types of filtration that they really provide two things, and it's the two main things. They can do the supplemental filtration and for high demand areas, but then they also bring in extra ventilation rates. Those portable air purifiers can bring in more ventilation where it's needed or where it's not enough. So some of the advantages, well, one, it's flexible deployment. So if you think about, hey, we're going to cram all these people into the gym, maybe bring out those portable air purifiers from the rooms that are empty now and bring them into that larger airspace to supplement the existing system. Or I know my son is in a classroom that doesn't have any AC or ventilation rates, so most of the time they have the windows open, but that's kind of a problem in the winter when it's really cold or when there's wildfire smokes outside. In a room like this, you can bring out an air purifier to increase that ventilation rate and have that filtration. So it can increase the ventilation and really take it where it's needed, either as a standalone or as a supplemental option. Concludes my slides. Thanks to everyone.
Awesome. Thank you so much, Luis. We really enjoyed hearing about you break down some of the regulatory requirements, some of the challenges, and then some filtration solutions that schools can use to meet MERV 13 standards efficiently. So with that, we're now going to transition into Dave Titus from Train Canada. He's going to be diving into share some real world success stories of schools that have implemented some energy efficient systems while achieving this MERV 13 compliance. So I know he'll be setting the tone a little bit by reinforcing some of the messaging that was previously said by our other two panelists, and then we'll jump right into it. So Dave, it's all yours.
Perfect. Thanks, Eva, and thanks, Jeffrey, Louis, so far. So yeah, my name's Dave Titus. I've been with Train for 17 and a bit years now. I started in Toronto for the first 7 and have been in Ottawa for the past 10 now. So I'm very thankful to have had a lot of experience over my career working with and supporting school boards across the GTA and into Eastern Ontario and Western Quebec. And have worked on a lot of IAQ improvement projects, done a few board-wide IAQ assessments that led to uncovering some real beneficial opportunities to improve IAQ across school boards, both from infrastructure and O&M standpoints. Recognize a lot of familiar names on the guest list today, so appreciate everyone's time, and thank you, Blade Air, for inviting me to be a guest speaker today. So I'd be remiss if I didn't just quickly take a quick step back. I know we're talking about indoor air quality and filtration specifically, more of a focus today. But this is, of course, part of the bigger picture of IEQ, or indoor environmental quality. Thinking about, not just indoor air quality, but thermal comfort, lighting, acoustics, things that are all so important when we talk about healthy spaces, and never more important when we're talking about the school buildings and learning environments for children. And of course, just a quick recap. When we're thinking about filtration, let's first consider what's in the air that we're breathing. Temperature and humidity, of course, the big factors that go into occupant comfort, what we can actually feel. And then the particulate matter, CO2, and the smaller things like VOCs, odors, and the ultrafine particles that are in the air that we breathe. All things to consider when we're making filtration decisions. During the pandemic, of course, a lot of new information was brought forward. There was a lot of focus, a lot of kind of changed lessons, changed standards and lessons learned. ASHRAE developed, a pandemic task force to really address IAQ. And while we're going to really focus on the cleaning aspect of that today, via filtration, I just want to remind everyone of the importance of these four pillars that were brought forward in terms of dilution through proper ventilation, maintaining proper exhaust control in your building, maintaining proper humidity levels in the building. All of this is just such a critical piece to maintaining healthy buildings. But of course, as I mentioned, we'll get into a bit more of the cleaning aspect of with the short time that we have today. Luis already touched on kind of the general challenges that the K-12 market and facilities face. He looked at this, a bit more from a holistic standpoint in terms of how do we deliver clean air for healthy buildings, how do we do it, in an energy efficient and sustainable manner, and make sure that we're maintaining airflow rates and following industry guidelines. Looking at this, dialing down a bit more into the technical specifics of HVAC systems and filtration, we really need to consider things like filter change maintenance and labor associated with that. Whether you're a city-centered large school board of 200 or 300 schools, or a smaller, more rural school board of 30, 40, 50 schools spread out across a large geographical area, filter change maintenance, as well as the logistics for storage, shipping, and all of the work that goes into regular filter maintenance is obviously just a huge amount of work for any school board to tackle. I'm not aware of too many current waste management targets, but of course, I don't think anyone would say that they're not interested in being aware of their environmental footprint and being as sustainable as possible. So anything that we can do towards minimizing landfill of all of the filter media that's replaced regularly and ends up in landfill is certainly something to be considered. And it's already been touched on as well, but of course, filtration choices have a huge impact on potential HVAC maintenance levels, unit failures, service calls, and of course, the cost associated with all of that. So when we think about filtration, we first need to think about the types of equipment and types of systems that we're considering. Here's your general list of usual suspects for HVAC equipment and air handling equipment that we see in schools. And we need to be aware of, the infrastructure, the age of the school, the specifics of the building, as well as the specifics of the equipment that we're looking at, that are all going to play a big piece in the choices made around potential IAQ improvements. So we need to consider, the filter types that we're using, the accessibility based on the equipment, maintenance frequency that we're looking at are all going to play a big part in this. In addition to that, how does the filtration that we choose actually impact the different pieces of equipment? Whether you're looking at, a very standard across school board packaged rooftop unit, runs constant volume, serves 2 or 3 or 4 school classrooms at a time. As a filter runs through a few months or multiple months of operation, obviously starts to load up and increase the pressure drop. What's that going to do for that type of system? We're aware that, as pressure drop builds up, that fan running at constant speed is just going to get choked back. And a dirty filter means the same unit is providing significantly less air into that classroom. A little bit different for some larger or slightly more advanced systems that use variable air volume controls. Those, as the filters increase, will actually use up a lot more energy, because those variable air volume systems are typically controlled to a discharge static set point. So the fan is always trying to provide the certain amount of air down the duct to the different rooms, to the different classrooms. And as that filter becomes dirty, the VFD or speed controller on that fan needs to increase, and the horsepower or energy consumption of that fan is going to increase to provide the similar amount of air across a dirty filter. And any type of system that we see so regularly in schools that include DX cooling using refrigeration compressors, as filters load up, are going to provide a lot more wear and tear on the components of that system, and lead to additional strain and potential failures or service calls on compressors, fan motors, and similar components in that equipment. So very simply, when looking at filtration choices, can we provide better air cleaning with lower pressure drop? And I think, based on the tone of this presentation and the webinar today, I think we know where this is going, but let's go to the next slide. A quick recap on, typical filters that we see all over the place, generally classified as passive filters. These are your throwaway type of filters, 2 or 4 inch pleated media filters or larger cartridge or bag filters. When looking at, your typical passive filter, these, as mentioned, they will load up, from the front, collecting all the dust until they have a very high pressure drop and need to be changed, during which time they'll be able to collect and hold a certain amount of dust capacity or, airborne contaminant capacity. Looking at one type of active filter, active filtration is a general term that's been around for a long time. Lots of different technologies that have been in the industry, some older ones like electrostatic precipitators, generally frowned upon and not really used much anymore due to their generation of ozone. Some really high-end air cleaners, such as catalytic air cleaners that use, the production of hydroxyl radicals to neutralize airborne contaminants. That come, highly effective but extremely expensive. And then the one example that I'm going to talk about here as the kind of most retrofittable and lowest cost example of passive filtration would be a polarized media air cleaner. So unlike your regular filter that front loads, turns into essentially a sheet of cardboard as it gets dirty and blocks a lot of airflow, the polarized media air cleaner will actually use a small charge to capture airborne particles 360 degrees around every fiber of that media. So they're able to collect more dust capacity at a lower average pressure drop and last much longer. Higher dust load capacity means that you don't need to change your filter as often. And in addition to those benefits of lower pressure drop and higher dust loading capabilities, your polarized air cleaners are much more effective compared to any typical passive or pleated filter or pleated media type of filter in capturing some of the smaller ultrafine VOC and odor particles that your typical MERV 13, MERV 8, or even a MERV 13 pleated media filter is really much less effective at capturing. So as this graphic obviously predicts, how do we find the low-hanging fruit? When looking at IAQ retrofits, where can we find something where we're going to legitimately move the needle in terms of IAQ improvements, doing so in a sustainable way, and of course, finding solutions that are cost effective. So two very, very standard IAQ improvements that I've seen and worked on many projects with and seen a lot of success with is targeting your typical 2-inch flat filters that are in the vast majority of HVAC equipment in schools. And even better than that, when you have equipment that has existing pre and final filters, very typically you'll see, a 2-inch followed by a 4-inch or a 6-inch or a 12-inch cartridge type filter. The 2-inch pre-filter, obviously being the low-cost filter to protect the more expensive filter with the higher MERV rating downstream. You might be changing the pre-filters quarterly, the final filters annually. Obviously depends on the school and the school board and the environment that school's in. And those are typically installed in some of the larger or slightly higher grade of HVAC equipment. So these are kind of the low-hanging fruit in the systems that I've typically found that offer really good opportunities for effective and lower cost IAQ improvements. So for the first example, looking at your typical rooftop unit, or this could be a unit ventilator or a simple piece of HVAC equipment serving, one or multiple classrooms. You have an existing flat 2-inch, might be MERV 8, might now be MERV 13 filter. And those again might be changed quarterly, twice a year, depending on the school board. I've worked on a lot of projects where we've been able to replace that with a standard 2-inch polarized media air cleaner that fits right into the existing filter rack. So retrofits are very, very minimal. There's a very small power requirement for the polarized media filter that can almost always just come from the control power transformer on the unit. Very rarely have I seen you have to run, a new dedicated, 120 volt or other power source to feed the, fractions of an amp required for that air cleaner. And what that's delivered in those retrofits is, of course, improving to a MERV 13, whether you already had a MERV 13 filter, if it was a 2-inch pleated filter. We've already talked about some of the challenges in terms of, short life cycle and high pressure drop. Or in this case, if you're upgrading from MERV 8, you have a MERV 13 solution plus the additional VOC and ultrafine particle removal that those typical passive filters just aren't really effective with. Next, of course, is you're going to reduce the maintenance and labor requirements around filter changes. Depending on the school, again, there's no guaranteed rule, but you'll definitely be going to at least half the frequency. It might be even less than that. So if you're looking at your typical previous filters being replaced quarterly, a similar polarized media air cleaner to replace that might be twice a year, might even be once a year, depending on the school. So you obviously have labor savings as well as a big reduction in filter storage inventory, landfill that's associated with that filter increase. Of course, going to the different air cleaning technology will give you airflow improvements and make sure that those units are able to maintain much closer to the design airflow and of course the equivalent ventilation rates that they're designed to do. You'll see reduced HVAC unit maintenance. Again, looking at the risk of failed compressors, strain on fan motors, bearings, sensors, all of these things that can happen as units have to work against higher average filter pressure drops. And the projects that I've worked a lot on, have financially been usually pretty appealing. simple paybacks and ROIs in the terms of a few years, and that was without any rebates. Now, thankfully, in a lot of places across Canada, there are great rebate programs in place. Currently, Save on Energy is actually funding 50% of filter upgrade and 4 years of replacement media costs for these types of retrofit projects. And with that substantial rebate, the ROIs that we're seeing in a lot of these projects are coming down to 2 years, 1 year, and often in some cases less than 1 year. So that rebate, as long as it's around, is obviously just a cherry on top for doing some of these projects. Very similar to the first one, but looking at existing units. And all of this, of course, it doesn't have to just be your retrofit solutions. This can be for new construction as well, where any new piece of equipment that would typically be selected or specified with your standard, 2-inch MERV 8 or MERV 13 filter. You can certainly look at providing some of these alternate technologies and solutions in new equipment as well. But I understand, we do have a lot of aging infrastructure, a lot of challenges in older schools. So I'm just, for now at least, just focusing on kind of the retrofit solutions. But when you have larger air handlers, larger package rooftop units, serving whole sections of schools or a whole floor or a whole wing of a school, multiple classrooms, those units will quite often have a primary and a secondary filter. Often, a flat 2-inch MERV 8 followed by a flat cartridge or bag of some sort, with a pretty substantial mid-life, mid-filter loaded pressure drop across both of those. Typically, those units are VAV systems where the fan speed is controlled based on a static pressure set point somewhere down the duct to make sure that we're always maintaining as close to design airflow as possible. So if we can replace those types of filters with a single rack of a 2-inch polarized media air cleaner in an angled configuration, I've seen some just huge improvements. Once again, similar to the last slide in terms of the IAQ improvements that you're seeing. You get the MERV 13 plus the additional VOC and ultrafine particle removal. But when we can go to a V-bank, you are now dropping your face velocity, dropping your pressure drop across that filter by about half. You're essentially putting twice the filter face into the same airflow, into the same air tunnel. So it stands to reason why all the pressure drops and filter life expectancy before a change is going to increase dramatically. And because of that much lower average pressure drop across that single V-bank filter as opposed to two filters, the second being a MERV 13 cartridge or of some kind, that translates directly to very significant energy savings in fan horsepower. With fan laws being, airflow is then related to pressure drop by a square relationship, which is then related to horsepower by a cubic relationship. If we can drop the pressure drop by a little bit, we're seeing a very noticeable reduction in horsepower. So that energy savings can also help to fund a lot of these O&M type of projects for a longer term. So that's kind of the general quick 2 examples I've seen. Again, I realize I've painted this with a pretty broad brushstroke, and that's just based on a lot of the successful projects that I've had the opportunity to work on, and the time limits. I wanted to respect everyone's time today. Going back to what Jeffrey had said, that there is no silver bullet. Every school needs to be considered, in a unique way. And I encourage everyone, of course, to work with your teams, work with your trusted advisors in the service and operation side of things to develop solutions that are going to be most effective for you. So with that, I'll send it back to Ava, and thank you all for your time.
Thank you, David. Really appreciate those insights. So I have been monitoring the Q&A and chat portion. We are entering into this portion of the webinar now. I do see one that has come through for Dave. Can you please explain how a V-bank design, which utilizes the polarized media filters you were just previously referring to, how this V-bank design will reduce the DP by 50%?
Yeah, thanks for the question. So the reduction is in comparison to a flat filter existing. So what I've seen in a lot of units is when you have an existing unit that has two filters side by side, there's enough space in that filter cavity to actually physically remove the two filter racks and install a V-bank filter rack, a simple 2-inch V-bank filter rack, which isn't a big construction achievement by any means. It's not a huge cost. So as you take the flat filter to a V-bank, you're essentially stretching out the face or the surface area, I should say, of those filters. You're putting a lot more filter face area into the same airflow, and when you're doing that, the pressure, the face velocity, which might typically be close to 400 to 500 feet per minute across a flat filter bank, sorry, is going to come down to 200, 250, 300 feet per minute. So as you push the same amount of air through many more filters at that angle configuration, the natural performance of a filter is going to give you a much lower pressure drop.
This one's for Dr. Siegel. They want to know what you think about polarized air cleaners inside HVAC systems. Are there any potential hazards? Are they able to produce MERV 13 conditions with low pressure drop?
So the short answer is, of course, it's complicated, but I would say overall, I don't have a great concern about any hazards, and they can provide high levels of filtration performance. The two kind of little caveats I'd put in there. One is that we don't have as much research as we should, frankly, on polarized air cleaners. And I think there's an enormous opportunity for kind of some in situ testing to see what the performance we actually get in the field, which sometimes is different from what we get in standardized tests. The other comment is fundamentally the way a polarized air cleaner works is it produces ions. Those ions enhance removal to the filter media. And there is some evidence in the literature that ions can have some negative health consequences. Having said that, I'm not terribly concerned about polarized air cleaners because, first of all, very few ions actually escape the device. And second of all, the overall production of ions, since it's there in the air cleaner to enhance removal, is quite small. But that's what I've heard. But I think that this is obviously self-interest, but I do think we need some more research, particularly on the long-term performance in actual buildings.
Yeah, and thanks, Dr. Siegel. I think I would like to jump in and just point out that we do things like ozone testing and these kinds of things in our polarized filters and things to ensure, because we're conscious of the importance of these safety hazards and making sure that there are no byproducts being produced. We're very conscious of avoiding that kinds of things. And so there are certifications like UL 2998 or what's called like zero ozone that are important to achieve and to have in these kinds of systems to ensure that we meet those safety standards that are very important.
And I concur that ozone isn't an issue in any polarized media air cleaner I've seen, but there can be, of course, be other things as well.
Awesome. Thank you. Professor Siegel, what's your opinion on charged filters, especially when ASHRAE says use MERV A rating? How will small particles, ultrafine, behave with charges added? Any science to add to this?
Oh boy, there is a ton of science, and I could talk all day about this, but the fundamental issue is, so this is a different issue from polarized media, just so everyone's on the same page. Many filters that are used in schools and in the marketplace in general have a charge added to them in the factory to enhance their removal. And the only question is, this is a great idea, it works quite well, but it does or it can decline as the filter ages. And so the idea of people using the MERV A rating is that you can be relatively convinced that your filter its performance will continue for the long term. Now, having said that, there is a substantial debate within the filtration community about whether MERV A is too conservative. So, for example, in some buildings, that charge won't decline very much, and the filter performance will be maintained, without even considering MERV A. And in other buildings, the decline will be a lot. And so the answer is, it's kind of an it depends type of situation. But if you want to be sure you're going to be getting the same filter performance at the end of the filter's life as you had at the beginning of the filter's life, then it's appropriate to use MERV A.
Okay, I see a question from Charlie Holt. For the Blade Air or the train team, so over to Dave or Luis, what is the number one objection that you are currently hearing or getting, and how are you overcoming that objection when talking with schools or learning facilities? So I guess, Luis, I can hand this over to you because I know that you've been in some conversations and can answer this. And then Dave, if you have any insights to back him up on.
Yeah, I think some of the objections or the hesitancy oftentimes comes from maybe that lack of knowledge and making sure that we are getting this new kind of what seems like a new technology, but it's really just about educating about what those actual benefits are, and showing our existent positive results where we have pilots and trials and actual real live results against these MERV 13s that oftentimes decrease in their efficiency, and we are maintaining the better air quality in their buildings, and showing those lower pressure drops and showing those energy savings and all those other important benefits. So I think in my opinion, it's more of a showing that the proof is there, in those real life examples that we are able to keep or improve upon those MERV 13 filtration standards. And in the case when against the MERV 8s, just plain improve on those and also show improvements in energy and reduce pressure drops.
Yeah, I mean, I think the biggest challenge I've seen when discussing this type of a solution with school boards is usually more there's the financial aspect for sure. I mean, a technology like this, a polarized air cleaner, is of course going to be more expensive than a typical throwaway filter. So everyone is always interested in looking at the longer term return on investment of, when does the labor savings coupled with the energy savings, when do you actually break even and those filters start to actually get some positive cash flow versus the continuing status quo. So that's one, but certainly the projects I've worked on have all been relatively low ROIs. The ones that have been challenging are where potentially higher degrees of construction modifications are required, but these specific types of filters are, because they do go into an existing filter rack, are really quite easy. So those projects are fewer and far between. The other challenge I've often been asked is, there's a 1,000,001 suppliers of a 2-inch pleated MERV 8 filter and MERV 13 filter. Whereas if you get into a solution like this, are you tying yourself to always have to buy replacement media from that supplier for the next 20 years? And while there is some truth to that, I mean, the benefits I think still outweigh that risk in terms of the financial analysis have been done, and they are very positive. And as well, there are other players in this market. This is a really impressive technology, and there are a few suppliers that make something like this. So, and there will probably be more coming out in the next few years as IAQ solutions like this gain more and more traction and more interest. So I don't think there's going to be as much of a concern around single sourcing or tying yourself to one supplier. I think there are multiple options out there, and that message has been understood by a lot of people that have gone with this type of solution.
I'm going to pose this to Dr. Siegel first, and then Luis, Dave, if you have any thing to add, please feel free. But what are your thoughts on where IAQ standards and regulations are going? Like, where are they going to be in the next few years, especially with the increasing focus on sustainability and these new regulations coming out? What are your predictions on what the next few years is going to look like?
Okay, I'll be a little bit of a contrarian, maybe to stir debate. I think that we should not rely on the fact that there are going to be new IAQ standards. I think the whole world of IAQ standards is very, very complex, and there's a ton of political barriers and other barriers to good IAQ standards. So I think that our future is going to resolve more around being able to provide good, clear information and a clear economic case for investing in IAQ. And I personally believe that we have many good technologies already available. We have many good approaches and strategies. And what we need to do much better at is demonstrating their value and in getting people to understand why it's so important to invest in them.
So, Luis, just one question for you. How does a polarized filter or the polarized media filter that we've discussed today, this technology, differ from bipolar ionization?
Yeah, thank you. That's a great question. Basically, bipolar ionization is what we call an additive solution. It adds ions that then attach themselves to the pollutants, and that's how removal is achieved. With the polarized filter, we basically send a high voltage charge through a dielectric media that then aligns itself in a polarized way. However, there's no additives and no ions that are actively being added into the air, as is with bipolar ionization or catalytic oxidizers and other similar technologies. This one is just creating a kind of a magnetic charge, if you will, that then captures the particles, and once they're added on, they can agglomerate as well. And because it's being actively charged, it doesn't lose that filtration efficiency that we kind of reference with that passively charged filters. That's why the MERV-A appendix was added to the 52.2, was for these kinds of passive filters that, yes, they have this kind of similar polarized charge at the beginning, but as they capture pollutants, they start to lose this charge. So this type of polarized filter is active, and what we mean by that is that it's always has that charge, so it doesn't lose it even as it starts to load throughout its lifetime. So it always maintains the efficiency at the end as it does at the beginning.
Thank you to our incredible panelists today. So to Dr. Jeffery Siegel, to Luis, to Dave for showing your expertise today. And always, we've explored why air quality is so crucial in schools, how to achieve MERV 13 compliance successfully, and practical ways to do so without compromising energy efficiency and budgets. So I hope today's session was very informative and has shown you that indoor air quality is not just essential for health and learning, but also is achievable with the right solution. So if you do have any questions, please don't hesitate to reach out to myself or any of the team members here. Thank you again for joining, and we hope to see you in many future sessions. Have a great day, everyone.